morning, students. Let us discuss about carbohydrate today. So carbohydrates are the major energy source among all the biomolecules. Carbohydrates will be defining it as polyhydroxyaldoses or ketosis. So carbohydrates will have more number of OH group, hydroxyl group, more than one. That is why we call it as polyhydroxy. And it will be either aldo sugar or keto sugar, which is based on the presence of functional group, whether aldehyde group is present or keto group is present. If aldehyde group is present, you call it as aldo sugar. And if keto group is present, it is keto sugar. So either one of the sugars will be there, never both the functional groups. So they contain hydrogen and oxygen in the ratio of 2:1. So as in case of water, it is H2O. The same way, similarly, hydrogen and oxygen will also be present in the ratio of 2:1. And this particular carbohydrate molecule will have carbon atom, hydrogen atom, and oxygen atom. So the general formula for any monosaccharide will be C6H12O6, and if it is a hexosugar. And the general formula for the any other carbohydrate will be CXH2O/10. So H2O will be the ratio of hydrogen towards oxygen, which will be 2:1, which will be similar to that of your water molecule. And carbohydrate is a major source of energy from which you will be all getting the function of work to do or any other physiological function, any other biological function. So the carbohydrates will be oxidized, and out of the oxidation, you will get the energy, and those energy will be used for any other function, either synthetic function in the body or biological function of the body or physiological function of the body. And this carbohydrate also will serve as the major component of the nucleic acid structure, in which you will have either ribosugar in case of your RNA or deoxyribosugar in case of your DNA. So this will contribute for the genetic structure of the nucleic acid. So the general structure and properties of monosaccharide we will see. So the carbohydrate basically will be classified into monosaccharides, disaccharides, and polysaccharides. So monosaccharides are also called as simple sugars. These simple sugars will also have the same kind of structures only, polyhydroxy, aldehyde, or keto as the functional group. This will be the most abundant carbohydrate which will be present. Monosaccharide will be the abundant carbohydrate which will be present. And though we take as polysaccharide, it will be converted to monosaccharide. And as monosaccharides, it will be utilized in the body. So major monosaccharide which will be abundantly present, which will be converted from any other sugar, will be the D-glucose. So this has 6 carbon sugar. This is 6 carbon sugar, and this will be sometimes called as dextrose also. So these monosaccharides will have either 4 or more carbon. Usually it will be 6 carbon in case of your glucose. And for other ones, it starts from 3 to so many numbers like hexa, hepta, like that. So these glucose or these monosaccharides also will be available in the cyclic structure, which is ring structure. So based on the different substituents of each carbon, you will have chiral centers. So you will have 1 carbon. Out of the carbon, you will have 4 substituents. So those, all the 4 substituents are different, means the particular carbon, you call it as chiral center. So those chiral center carbons will exist as stereoisomers. So these stereoisomers are also present in nature. As such, you will have a specific stereoisomers. So these stereoisomers are biologically significant, biologically very important, and any other metabolic reaction, any reaction which happens in your body, either oxidation reaction or reduction reaction, which will follow stereospecificity. So this generally, the monosaccharides will be colorless. Of course, it is crystalline solid and it will be freely soluble in water. And it will not interact with nonpolar solvents. So it cannot be dissolved in nonpolar solvents. And of course, this will be sweet in taste. And these are unbranched carbohydrates. Since it is only monosaccharide, only 1 sugar will be present, and you don't have any branches in the monosaccharide. And you will have only the single bond. There is no double bond structure in case of your monosaccharides. So you can write it in the form of open structure, or you can write it in the form of ring structure also. So I'll just show you some of the structures. So open structure, you can see CHO. So this will be aldehyde group, and you have 1, 2. So more than 1 hydroxyl group. So you define it as polyhydroxy. aldo sugar. This is aldo sugar since aldehyde group is present. So you have to remember CHO will be the aldehyde group. And in case of your dihydroxyacetone phosphate, again, it is a 3-carbon carbohydrate where you have keto group. C double bond O alone means it is keto group. If it has CHO means aldehyde group. So you have 2 hydroxyl group here. Here also more than 1 hydroxyl group is present. So it is also called as polyhydroxy. So let us see in case of your glucose molecule. So you can see 1, 2, 3, 4, 5 OH group. So polyhydroxy, CHO is there. So it is aldo sugar. So you call it as aldohexose. Since 1, 2, 3, 4, 5, 6 carbon atoms are there, you call it as hexose. Since aldehyde group is there, aldohexose you call it as. So this is actually the structure of D-glucose. The D-glucose is also called as aldohexose. Likewise, in case of your fructose, which will be present mostly in the honey, this also will have 1, 2, 3, 4, 5 OH groups. So you call it as polyhydroxy. And here you have only C double bond O. So it is called as ketohexose. So when you define it as polyhydroxy ketohexose sugar. So likewise, based on different number of carbon atoms, you will be classifying your carbohydrate also. So now based on the functional group, we already saw either it can be aldo sugar or it can be keto sugar, or aldoses you will call it as, or ketoses you will call it as. So if it is CHO like this, you will be calling it as aldo sugar. If it has only C double bond O, you will be calling it as keto sugar. So now based on the number of carbon atoms, again you will classify the carbohydrate into either tetroses, pentoses, hexoses, or heptoses. Just see the diagram. So here it is 1, 2, 3. You have 3 carbon group. This is trioses. Again, here also, though it is a keto sugar, it has also 1, 2, 3 carbon atoms. It is again triose. But the thing is, based on functional group, you call it as aldotriose. And here, based on the functional group, you call it as ketotriose. And in case of your glucose, 1, 2, 3, 4, 5, 6 carbons are there. So you call this as hexose sugar. And again, if it has 5 carbon, 1, 2, 3, 4, 5. In case of your ribose, you have only 5 carbon atom. So you call it as pentose sugar. So likewise, you have hexose sugar, then you have pentose sugar also, you have heptose sugar also, you have octose sugar. Like that, you will be having different number of carbon atoms. Based on that, you will have different kinds of sugars. So the sugar's functional group also will change. So always whenever we name a carbohydrate, especially the monosaccharides, you will be naming based on the number of carbon atoms along with its functional group. So number of carbon atoms will give you which kind of trioses it is, like trioses or tetroses or pentoses, like that. And to that, you will be adding either which functional group which is present, either aldo or keto. And also you have to observe one thing, either aldehyde group will be present or keto group will be present, but never both the groups will be present in any of the monosaccharide. So as I have told you, it is also present in the nucleic acid. In case of your DNA, it will be deoxyribose sugar. In case of your RNA, you call it as ribose sugar. And again, you have based on the chiral atom. Chiral atom in the sense, this is 1 carbon. Let us say, for example, this is 1 carbon. Here C double bond O, one side OH is there, H is there. So if you have same substituent, then this carbon atom will not have any chiral center. If it has different substituents, as in case of the center carbon atom, you just check here OH is there, here C is there, here C double bond OH is there, and the other one is H. So this has different substituents. When a carbon atom has different substituents, you call this carbon atom as chiral center. A number of chiral carbon atoms will decide number of stereoisomers which is present in the structure. So you have a general formula for calculating how many number of stereoisomers a particular carbohydrate molecule will possess. So you have 2 to the power n stereoisomers. So to calculate that, you use the formula 2 to the power n. So n denotes the number of chiral carbon atom, or you call it as chiral centers. So if you have only 1 chiral carbon atom, 2 to the power 1, so 2 you get. So how many aldo sugars you will have? Then you will have only 2 for any glyceraldehyde structure. So let us say for this structure, you have only 1 chiral carbon atom. So if you substitute in this formula 2 to the power 1, it is giving you answer 2. So glyceraldehyde will be existing in the form of 2 stereoisomers. And in case if you have 4 chiral carbon atom, in case of your glucose, you will get 16 different kinds of stereoisomers. So you have to remember 2 to the power n will determine the number of stereoisomers which will be existing for the particular sugar molecule. Whether it is triose or tetrose or pentose, it depends on the number of chiral centers or number of chiral carbon atoms which is present, which will determine the stereoisomers. And any 2 sugars which are different in only one configuration around only 1 carbon atom. So all the structures are same, only 1 carbon atom you have different distribution or different structure conformation. Then you call it as epimers. So here based on chiral center, here based on the location of OH group and H group for only 1 carbon atom. If there is a structural difference for only 1 carbon atom, you call it as epimers. And again, the formation of ring structure also is possible with the help of alcohol and aldehyde group. So for example, you have your aldehyde group and the 5th carbon's OH group. So this 2 will form a ring structure. So if aldehyde group is reacting with alcohol, you call it as chemi-acetal. And if keto group is reacting with alcohol, then you call it as chemi-keter. So you can see the structure. So if this aldehyde is reacting with this OH group, 5th carbon's OH group, then you call it as hemiacetal structure. And again, this keto group is reacting with the C5, 5th carbon OH group, you call it as chemi-ketal structure. So both the structures will be of greater importance, both will be existing. So you don't have to remember the structure, but you have to know how the structure looks like. So this is a glucose structure which we saw in the open conformation. You call it as Fischer's projection formula. So same thing if you convert into ring structure where you get hemiacetal ring structures. So both things are reacting. The CHO and OH is reacting. Then you will be getting a 5-membered ring structure. You call it as pyranose ring structure. That's why you call it as glucopyranose structure. So same way, you also have the formation of another kind of 5-membered ring structure. You will be calling this as fructofuranose structure. So these structures are possible. These structures are biologically present and naturally also present in the physiological system. And all these monosaccharides, whatever the monosaccharide we saw, all the monosaccharides can be oxidized by any oxidizing agent, like cupric ions and all. And here, if glucose and any other monosaccharides, if you take, it can reduce your copper to cupric ion. So this you call it as reducing sugar. So if any glucose or any of the monosaccharides, if it is capable of reducing copper to cupric ion, then you call those sugar as reducing sugar. So in the labs and all, we used to test presence of glucose by adding Benedict's reagent or Fehlig's reagent. So if you add little glucose solution, add either Benedict's reagent or Fehlig's A, Fehlig's B solution and heat it or keep it in boiling water bath, you will be getting brick red color. So that tells you the presence of cupric ions. So if glucose is present, the glucose will convert your copper, which will be blue in color, to cupric ions, which will be brick red in color. So if glucose is present, that reduction of blue color to red color will be taking place. So those glucose means those monosaccharides as well as glucose, which are capable of reducing copper to cupric ions, you call it as reducing sugars. So by this we'll complete the monosaccharide. Disaccharides we'll study in the next class.